stuff like that at you?
Yeah, you just like, and then like everyone.
Well, listen, the thing that messed you guys up is that it's new. It's new. You guys have never done anything like this in a class before. That's it.
Like even like algebra, like everything was like it felt like kindergarten. It was so easy.
What, like last year?
Yeah.
You guys are little equation solvers. You guys do really well with algebra. So this is new. I'm asking you guys to learn a new skill. Okay? All right. So what do we do first?
Given.
How many?
2, 3.
There's 3 of them. We can write that all as one step. So x is midpoint of wy. X is midpoint of VZ. No, why did I do that as step 2, dummy? One step.
Do we have notes today?
2 step, no. Given. Oh, wait, and we're missing one, right?
Yeah.
VZ.
I missed that one. I didn't see that at first.
What? The one that was there? It's a pretty important one. Yeah, we definitely need that to prove them. Okay, so those are the things that I have. What should we do after that? Jillian, what do you think?
I did definition of midpoint.
I like it. So what are the 2 things you said equal?
WX and XY.
Okay, and then also VX and XZ.
X and XZ.
Okay. So I'm going to just do both of those. Doesn't really matter what order we put them in. WX congruent to XY. Definition of midpoint. I think no matter which way you did your proof, you have to have that somewhere in there. All right. Okay, we used our givens. We used our vocab in the given. Now we would go to our diagram. What did you guys do after this? Jillian, what did you do? SAP. Molly, what did you do?
Oh, I messed it up.
Got it.
Yes.
Yeah, I would do SAP. That's what I would do next. So we have to do SAP twice. So once with VZ and then once with WY. And I know that those things are actually equal to each other because that's one of those givens up there. So we're going to use that here in a second. So VZ is congruent to the VX plus XZ. So I'm going to use congruence. I'm going to use lines above it as well, too. Where's your worksheet at? And then the other part is WY. So WY is congruent to WX and XY.
The Jets or Dolphins went last night.
Tyler felt broke his leg.
That's so bad, bro.
Poor dude.
Did you see that?
No, but my buddies were talking about it,
Yeah,
so.
But his leg was like, I don't know, it was so.
Yeah, it's like Nick Chubb all over
Fantasy,
again.
Like this isn't fair.
Was it the knee?
No, it was like literally like, I think it was like, it was his femur.
That's the toughest one to break.
Listen, what?
His toe was pointed like that way.
Yeah, dude, his whole leg, he's literally stuck like this.
Whew, not good. All right, so segment addition postulate, we can add those 2 smaller segments together to equal the larger segment, okay? And it gets a little tricky from here, because from here it's like, you can't just make it a 5-step proof because there's a lot that we have to do yet. Jillian, what'd you do?
For segment addition, whatever, SAP, I didn't have that. I just put like VX plus XC equals VZ. Is that the same?
VX plus XZ equals the same thing. I just put it in a different order. I did big equals small plus small. You did small plus small equals big. It's the same thing.
Oh.
That's what I'm saying. All right. Now where do I go from here?
You substitute.
Okay. I mean, that's our next step, substitution, right?
Yeah.
Good catch. What would we substitute?
You could substitute since you,
You're right. That's what I would do next is substitute. When you...
You substitute VZ.
Mhm.
Wait, no. Wait. Oh, I know. Wait, no, you substitute X I give up.
Wait, can I-
Wait, no, x.
It's
Oh wait, they're all equal. So you would just put. When you just substitute. I don't know how to say this.
Do you want to write it?
Since aren't Vx is equal to xz, and Wx is equal to xy when you just substitute all those. That's what I meant to say. I don't need to write it. Or is that wrong?
We're going to at some point. Can't do that just yet. But we're going to at some point. Oliver, what were you going to say?
Oh wait, you could. Okay, no, he got
It
it.
would be Vx plus xz equals Wx plus xy.
Yes. So what Oliver wants to do is he wants to he knows that these pieces are equal to each other right here because of that given up there, right? So then I'm going to substitute those pieces in, and I would get Vx plus xz is congruent to Wx plus xy. Also, please watch the recording so you can hear Carter be the teacher for a second. I mean, he's just like straight had my iPad, so. All right, so then what's the reason for that? Carter said substitution, right? That's what Oliver set us up with there. Okay, but now we're going to do what Carter said, okay? Because Carter, you said that, okay, well, all those little pieces are equal, right? So let's substitute the little pieces in for each other. So instead of writing Vx, I'm going to write, what do I want to end up with? I want Vx and Wx, right? Okay, so instead of writing actually xz, I'm going to write Vx, because I know that Vx is equal to xz. So my fifth step would be Vx plus Vx, because I substitute this here. And then I want Wx, so I'm going to substitute this here.
So Wx plus Wx.
Yes,
And then you just subtract,
combine.
combine.
Mhm.
But then wouldn't that make it 2?
Mm-hmm.
That,
And you multiply.
Yep, or divide, either way.
Yeah.
Yep.
mm,
So then substitution here again. And then property. Don't be lazy, Mr. P. Wait, Mr. Pacifico. There's already a Mr. P here. All right. And then I would combine, right? So Vx plus Vx is 2Vx. Is congruent to 2Wx. And then what reason would I use when I combine like terms? Substitution, very good. And then what now?
divide.
Multiplication or division. I'm cool with either way. You would multiply by a half or divide by 2. Either way, you would get Vx is congruent to Wx.
And then when you're doing definition of midpoint, do you just write what's equal to each other?
Mm-hmm.
Okay. So, can you go back up? Yeah.
So like VZ. X is the midpoint of VZ.
Yeah.
So I wrote, based off that Vx is congruent to XZ.
Oh,
right
okay.
there.
And you write Wx is congruent to xy.
Yes.
Okay. Alright.
Definition of midpoint.
Okay.
Does that make sense?
Yep.
That's all I got, 7 steps. Somebody do it, they feel like in a legit way less than 7.
6.
This one was long. There was a lot of things you had to do. Bryce, what'd you do?
No, can you go back down?
Sure.
Don't you still have to do a definition of congruent segments?
Do I? Did they? No, because in the notation, they used congruent symbol and then they wrote the lines above it. So that's what I did there, congruent symbol, and then, yeah. I'm glad you checked on that, but I'm cool. What'd you say, Parker?
For step 4,
Okay.
we have Vx plus xz.
Yep, I'm looking at it.
It says, was it step 2?
It's watered. Mm-hmm. We're substituting it in for step 1. So like, this represents the 2 big segments, Parker. I know that they're congruent to each other. And then, like down in step 3, I broke those big segments apart. So VZ, which is right there, equals these 2 things added up. And then WY, which is right there, equals those 2 things added up. And since I already knew that they were equal, I just set the right sides equal to each other.
I understand.
Let me point, maybe? Sorry, Sam. Okay. These represent the big segments. I know that they're congruent to each other. It was given to me. I did segment addition postulate to show, like, hey, this big segment is these two segments added together. This big segment is these two segments added together. If I know these are equal to each other from up here, I can just substitute this side in for this side in for that, and then that's how I got that.
Okie dokie.
Where'd I lose you?
Huh?
Where'd I lose you?
No.
Me neither. Yeah, just replace them. Substitute them in for the pieces that you know are already equal. Brielle.
I did like the same thing that you did, but I just combined all the like substitution things into one.
So then did you go from like here to there?
Like, I also flipped the segment addition postulate and the definition.
What do you mean you flipped it?
Like I
Okay.
did, SAP first.
Okay. All right.
And I did the definition of midpoint, and then I just went into the two WX is congruent to 2EA.
I don't know if you could do that. Because you have to have them equal to each other at some point. I would have to really look and see if you were able to do that. Like, I'd have to look at your work. I'm not so sure that you can, though. Because I think you'd be skipping too much substitution. But I could be wrong. Because I've been wrong before. Haley, what's up?
I like had a question, but I think I just did it wrong. Because you know how you put like WX and XY equals WY, and then VX plus XZ equals VZ?
Yeah.
Like, couldn't you just put that then down without having to do all that other substitution? Because you know that those two are equal to each other, so then you just put the end like in there, or is that just completely not right?
Are you saying you go from,
Step 4 just
Okay.
to step 7.
oh, from here to here?
Yeah. Because, like, you already know that VZ.
Yeah. Do I know that XZ and XY are congruent, though? I don't think I do.
Yeah.
That's why you can't. I would say this. You can subtract something from both sides of the equal sign if it's not the same thing, but if you know it's equivalent, which I'm going to do that later in a proof here in a minute. But I would have to know these two were congruent first to subtract them and then get to there. But if I knew that those were congruent, I would have saved 3 steps. So, yeah, it would have been much faster. But I don't know that they're congruent. So, great questions. I never mind answering questions because you guys genuinely have great questions. So, all right, we're going to do skinny crayon for this one. Okay, let's start giving. Ray BF bisects AFC.
We're going over all these.
I feel like we should, right? I feel like we should. All right, Ray BF bisects angle AFC. Listed are given. What's our next step?
Definition of angle bisector.
Good. So, vocab in the given. In this case, I have it. I know an angle's being bisected. So then what would that be? Which angles? So AFC is being bisected.
Mm-hmm.
What does that mean, Jillian?
Angle 1 and angle 2 are congruent.
Good. So I would use this notation. The same thing that Jillian just said. Angle 1 is congruent to angle 2. What's our reason? Definition of?
Angle bisector.
I like it. Cool. I know that 1 and 2 are congruent. Now I want to show that 2 and 4 are equal to each other.
Ooh. Ooh, I know how.
Molly's got it. What do you got, Molly? I need to use vertical angles. Specifically vertical angle theorem, right? So I would say that angle 1 is congruent to what? Okay. Vertical angle theorem. Oh, I know what that extra quiz is for. Okay. All right. I like it. I know 1 is congruent to 2, and I know 1 is congruent to 4. Substitution. What's going to be congruent now, Molly? Angle 2 is congruent to angle 4. Substitution. All right. Hey, we're almost there. Look back at my proof statement. I need to show that measure of angle 2 equals the measure of angle 4. What's my last step?
Did we not just do that?
No, unfortunately not.
You have to make them uncongruent.
I know what you mean by that. We have to change the notation, right?
Definition.
Definition of congruent angles. So the measure of angle 2 equals the measure of angle 4. And then the reason for that is definition of congruent angles. I've been lenient on that in the past, but I am going to make you guys use that proper notation. Do we like skinny crayon? I like skinny crayon. Skinny crayon's not bad.
Yeah, it's fine.
It's easy to read. Okay. All right, that one wasn't too bad. Brielle, can you see well enough? Are you good? All right. Okay. The next two. Oh, yeah. It's important that we do this one. All right. Let's start givens. Angle VZW is congruent to angle YZX. Given. And then where do I go from there? I don't have any vocab in my givens, right? Yeah, so I got to use angle addition postulate. I got to go to my diagram. Okay, so I haven't even looked at what angles I'm breaking up yet. So they give me VZW is congruent to YZX. So VZW, oh, that's the little guy. And that's congruent to YZX, which is the other little guy. So I know the little guys are congruent. I want to show the big guys are congruent. So VZX and WZY. So I want to show that those are congruent to each other. So I think you guys are right. We need to do angle addition, break some stuff up. So angle VZX is congruent to angle VZX. So VZW plus angle WZX. And then angle WZY is congruent to angle WZX plus angle XZY. I need to take attendance.
Makes sense.
What's my reason?
Angle addition postulate.
Yes, it is. Did I take attendance already? They've already hunted me down twice today. What's up, girlies? Is the order messing you up?
Yeah.
Yeah, sorry. Do you guys like it when I put the big angle second? Would you rather me do it big equals the big angle? Okay, my bad. All right. Are we good from there? Okay, so I know the small parts are equal to each other. I just broke them up. Now let's look at what we have. Like I want to get to the big angles. So I want to show that like these two pieces are equal to each other. So I have to like work my way to that. Any ideas? What do you see there? What do you think? What's common amongst those two angle breakups? Yeah, WZX is in both of them. Do you guys see that? What? So like WZX is here, and then it's also here.
Wait, how did you?
Did you find it, Oliver?
I wrote W2. I don't know why.
Okay. if you look at the other pieces that are a part of that breakup, it's VZW and XZY. What do you know about those? They're congruent. And I messed up the order with what they've kind of referenced, and so sorry if that messed you up. But I know that those are congruent. So what I could do is I could start with the fact that those are congruent, and then what could I add to both sides of that statement that I just starred? WZX. Because then I would have those little angles plus WZX, and if I add those together, that gives me the big angles. So I would have angle VZW. Oops, that looks really bad. Plus angle WZX is congruent to angle YZX plus angle WZX. So what I did was I added WZX to both sides of that statement up above. So since I added the same thing to both sides, what property is that? Yeah. Not that I expect you to remember every single example and homework problem that we've done, but we've done a couple of these. But what is VZW plus WZX? From up above, it's VZX. So angle VZX is congruent to, all right, and then same thing. So these two angles added together is equal to WZY. So angle WZY. And what reason can I justify that with? Substitution. I don't know if any of you are dyslexic, but like, oh my gosh. Can you imagine trying to keep all these letters straight if you had trouble with that? Like that's
I'm dyslexic.
got to be tough.
I'm joking.
Okay. Well, that would be insanely tough. Like if you were dyslexic, like trying to keep all those letters straight, like that's like,
Yeah.
I don't know. That sounds really difficult.
I can only imagine.
All right. Can we hold on for one more proof?
No.
Okay.
And this one actually was pretty easy, so yeah.
Nice. We can do this one the easy way or the hard way. All right, we'll put it on easy mode. All right, angle 1 is congruent to angle 2. What reason is that? Okay. I listed my givens. Is there any vocab in the given that I can use?
No.
Wimp womp. So now we got to go to my diagram. This wouldn't really be angle addition postulate, right?
Why?
It's linear.
Yeah. So I can use the fact that it's linear
It's 100.
as opposed to it being angle addition postulate. Okay. So what's my linear pair? 1 and 3?
And then
Okay, so then let's say angle 1 and angle 3 form linear pair. And then I can do the same thing with angle 2 and angle 4. Okay. Form linear pair. Reason? Very good, Molly.
linear pair, that's what I put for definition. Would that like get what's off?
If you just said linear pair, it depends what kind of mood I'm in, honestly.
I put that as my third step.
You did that as your third step
I don't even know what I did.
for your second step?
Well, for my second step, I said angle 1 and 2 are supplementary. And then put supplementary here.
I mean, 1 is supplementary to 3 and 2 is supplementary to 4, but I'm not sure either. Okay, well, if I know that the angles form a linear pair, what can I say about them?
Congruent.
Now that they're congruent,
What?
what? They equal 180. I would say that if they form a linear pair, I know that they add up to equal 180. I should say that they're supplementary and then say they add up to equal 180, but I'd be okay with you guys just saying that angle 1, well, actually I should say this. Use proper notation, Mr. Pacifico. measure of angle 1 plus measure of angle 3 equals 180. And then measure of angle 2 plus measure of angle 4 equals 180. And then we can say definition of linear pair. I'd be fine with that instead of use definition of linear pair twice. Brielle.
Would you have to do step 2 then? Like, I just wrote measure of angle 1 plus measure of angle 3 equals 180, and then.
Definition of linear pair.
Or, yeah.
That's what I did last period. So I skipped step 2 last period. And step 2 would be the safe route, but I would be okay with it if you went straight to step 3. Emma, is that what you're going to say too? Okay. What do I know if they're both equal to 180?
They're the same.
They're congruent. They're equal to each other, right? So then they're the same, right? So I could say that measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus the measure of angle 4. Why? There's just a bunch of snakes in here all of a sudden. Substitution is what we're going to use. Good. I need a snake in my house right now.
What?
Oh, you,
I have a mouse. It's running around. I've like, my wife caught one with like her bare hands. She didn't like grab it, but she saw it like jump in a bin, and then she like hurried up and like put something on the bin, and then just like put it outside. But I have like a dozen mouse traps set up, and she still like caught it in the bin because she watched it go in. But I like seriously, like I don't have a cat. Like I'm debating borrowing somebody's cat for the weekend. Like I have an exterminator that's doing it, and he like can't get him either. They're eating my chips, man. Like I'm trying to pack chips for my kids' lunch, and they're eating my chips. Like I'm over it. I'm recording this. All right. Anyway, I know that those are congruent. Now what can I say? Yes. How can I jump there, Emma?
Because you just subtract angle 1 and angle 2.
I know that 1 is congruent to 2, so I can subtract that from both sides of the equation. So essentially I'm subtracting measure of angle 1 minus measure of angle 2. And I can do that because I know that those pieces are equal to each other. So I can go straight to saying measure of angle 3 is equal to measure of angle 4. Some might say that's skipping some steps, but I'm okay with it. Okay, I'm almost done, but I have one more step. What's my last step?
definition of congruent seconds.
Close angles, definition of congruent angles. Because that wants to show angle 3 is congruent to angle 4. So angle 3 congruent to angle 4. And then the reason for that is definition what? Of congruent angles. All right. Rapid fire property time. You ready? Here we go. Alina, what's the first one? If DE is congruent to FG, then FG is congruent to DE.
Reflexive?
Not reflexive.
Symmetric.
Yes. I'm trying to remember if you messed them up on your quiz. There's a couple of you that like mixed them around, reflexive and symmetric. If there's an if and a then statement, what is it?
Symmetric.
Yes. If it's the same thing on either side, like number 9, there's no if and then. It's just a real short statement. Reflexive. I'm going to just skip right there. It's probably the only one Alina missed, and I like called on her first. What about number 6? If xy is equal to wz, then xy plus tu equals wz plus tu.
Addition property.
Yeah, it is, Mallory. Addition property. I should say of equality. And for the last one, I should say of congruence. But I haven't really been a stickler on that, so. If it's an equal sign, it's equality. If it's a congruent sign, then it is congruence. If 1 and 2 are vertical angles, then angle 1 is congruent to angle 2. What is that?
Definition of vertical angles.
No.
Angle theory.
Yes. The theorem is what tells you that they are congruent to each other. You missed a half point on the quiz if you said definition of vertical angles for something like this. Oops. Vertical angle theorem. I kind of like skinny crayon. I think I might switch to skinny crayon. All right, if measure of angle 1 plus measure of angle 2 equals 90, and measure of angle 2 equals measure of angle 3, then the measure of angle 1 plus measure of angle 3 equals 90.
Somewhat complementary.
Nope, you would think so.
Definition of gradient.
Nope,
Transit.
it's just substitution.
What?
Yeah, it's just substitution. And it's tricky, right? Because it talks about like complementary angles and it talks about adding up to equal 90. So it's tempting to say one of those other ones, but it is just substitution property. Carter, what are you doing right now?
I don't get that one.
Yeah, I know you don't. I want to bring you back into this because this is where you missed most of the points in your quiz. You logged off there for a second. Okay, well, then let's talk about it.
It's substitution. Oh wait, no, I see it now.
We got to start at 5.
So he substituted the 2's.
Yeah. Are you talking for number 8?
Yeah.
Yeah.
No, I understand
'Cause you
the
know-
other ones.
You know 2 is equal to 3, so they substituted
Okay, wait.
3 in for 2.
Yeah.
You're okay on the other ones?
No.
I didn't
Just
think
saw
so.
it.
Okay.
Okay, I know what vertical angle theorem is, but
Are you cool symmetric, the first one? Just flipping the side of the equal sign or
yeah,
congruent
I
sign
got
that's
that.
on?
Why'd you put of?
Of congruence?
Yeah.
I haven't been a stickler on that. If you just put symmetric property, that's fine.
okay.
But I just wanted
Yeah,
to...
no, I know that one.
Addition property, you cool with that?
Mhm.
Okay. And then vertical angle theorem as opposed to definition of vertical angles. The theorem is what tells
Yeah,
you...
I'd put that.
The theorem is what tells you they're congruent to each other.
Okay.
All right, we caught up to speed? All right, stay with
Oh
me.
wait, no, for that one I did put substitution for number 8.
Swish. Like I said, it's easy to get caught up in like being right angles or complementary angles. Okay, number 9, those two things being equal to each other reflects a property. We talked about that. Okay, number 10, if 4 and 1 are supplementary and 3 and 1 are supplementary, then 3 is congruent to 4. This one's tricky. Last period couldn't get it. Not transitive. Not substitution.
Definition of supplementary.
Not definition of supplementary angles.
Addition.
Not supplementary theorem.
Supplementary.
Angle.
Kalia? I like it, but I'm going to switch the order of the word. It's congruent supplements theorem is what it is. We haven't done that one in a minute. It's been a couple days since we've done that one. But yeah, it's congruent supplements theorem.
Next one's transitive.
Do you guys agree? Next one's transitive property? I agree. And how do I know it's transitive?
Because the measure of angle B's are next to each other.
Mm-hmm. Technically, I would say transitive property of equality, but again, haven't been a stickler. All right, if 5 and 6 form a right angle, then 5 and 6 are complementary. This one's kind of a tricky one, too.
Is this the definition of complementary?
Not definition of complementary. Yeah, it's complements theorem or complementary
I don't
theorem.
even know. I don't even know if that was a thing.
Yep. We talked about them a couple times in class. There's 3 theorems that relate to complements, and there's 3 theorems that relate to supplements. Jillian?
There's definition of complementary angles, would it say like 5 and 6 equal 90?
Yes. So if 2 angles add up to equal 90, it's definition of complementary. If 2 angles add up to equal 180, it's definition of supplementary. If like number 10, 4 and 1 are supplementary, 3 and 1 are supplementary, then 3 is equal to 4. That's congruent supplements. Or you could say like if 4 and 1 are complementary and 3 and 1 are complementary, then 3 is congruent to 4. That would be congruent complements theorem. And then which one didn't I do? Complements theorem would be, yeah, if 2 angles form a right angle, then they're complementary. Supplements theorem would be if 2 angles form a linear pair, then they're supplementary. That was supplements theorem. All right, if 7 and 8 are complementary, then 7 plus 8 is 90. What's that? Yes, in light of what I just said, it is definition of complementary angles. Woo!
We're done.
We did it. It was long. It was long. Hey, your test is on 2.6 to 2.8. Big thing we talked about in 2.6 that we haven't talked about in a hot minute is what type of proofs. Those algebra proofs, just like 2-column algebra proofs, right? So I'm going to give you, you remember those? It'd be like if 5x plus 4 equals 20, prove that x equals 2 or whatever. Yeah, or x equals 1. Yeah. Nice, perfect. I love that. Let's do some practice with those. Oh. No, I'm going to give you a review that you guys are going to work on for the rest of the period, and then we'll go over them all. I refuse.
But is there a test or something?
Test on Thursday.
Seriously?
For serious. And then we're done with chapter 2. Now, I promise you this. Test. Thursday. I promise you this. After you guys take this test, on Friday we'll take a break from proofs. You have 15 minutes now.
I'm done with these packets.
Okay.
Are we serious?
You are welcome.
Can you give it to me, Leon?
It is, bro. This is like not
Guess who's on? Oh my god.
like what? Fortnite.
Really? Are you disappointed that I do all my notes on numbers instead of...
Oh, yeah. Oh, yeah.
You okay? Do we need help getting started? No. How about this? You guys, do you want evens or odds?
Even.
Do the evens.
Let's go.
Is that an okay compromise?
Nah, I want to do all of them.
All right, do them all, Carter. Do the evens, okay? All right. It switches up the types of exercises.